So, hi everyone, my name's Rebecca and I'm a front-end developer currently working with Node and React and Redux and all their friends. And I have a few thoughts about debugging that I want to share with you guys. There should be something useful in here no matter how deep down this rabbit hole you've been before, but I really want to hear your thoughts also, so please feel free to tweet at me. I'm at Rebecca on Twitter. So I'm just going to do a quick plug because we are looking for people at the moment and we have a really awesome team. I don't know if you can tell, but that's actually me in the top right and there's a couple of other people in the audience who are also in this photo. We have, we have an awesome team and working on some really cool projects. So if you're looking for work, hit us up. Okay, so the polls are in, and I'm pleased to see that you guys reflect this. As you can see, it's pretty safe to assume that the majority of front-end developers are using console.log the majority of the time to debug their code. And it's understandable because we've been conditioned to use simple text editors like Notepad, Atom, Sublime Text. And a large portion of web developers have just never really had that exposure or experience to a formal or traditional debugging process. And the browser console is a pretty nice way of inspecting our logs, right? It's simple and it's easy, so why would we change it? Well, because there is so much more. So just sticking to the console for now, I don't know if you knew, but there are a heap more methods on that console object that some of us don't even know about. Console.table is one of my favorites. It's really nice for debugging arrays to be able to see and compare all the different objects in your array. And console.dir is one of my favorites as well because it's really great when you want to log out the actual JavaScript representation of your DOM node rather than the HTML markup. It's even better in Node. So console.log obviously spits out our objects in black and white, not super readable, and also it only goes 2 levels deep. So you can see here the geo object, we don't really get any information about what's actually inside that. Whereas console.dir, we can pass through a couple of configuration options, and we get a lot more readable output. And there's also some really handy features of the console coming up. So this is in Canary at the moment, which is the nightly build of Chrome, which is really useful if you want to check out what the latest features are. But do keep in mind it can be a bit unstable and a bit slow sometimes. But yeah, so for instance, here we have on the left a new way of categorizing our logs, which is really handy. And also you can group similar logs together. So it's really great when you've got a lot of noise in the console and it's hard to find what you're actually looking for. Okay, so let's say we've been working for console, with console functions for a while now, and we want to step it up. So what's next? Well, the dev tools have some other really handy features, namely the DevTools debugger. So the simplest way to activate this is by adding the debugger keyword to your code, as you can kind of see that I've done here where it's highlighted. And yeah, when the browser hits that keyword, it will pause the execution of your code and allow you to inspect it. So for example, here I can hover over the mysteries object and I can log out my local variables in the console, which I wouldn't normally be able to do. I can inspect the entire scope of the code at that point. And I can also step through my code line by line to further inspect it. So one tool that's almost essential when using the debugger is blackboxing. So this lets us prevent the debugger from stepping into certain scripts when we are debugging code. So here I was debugging a React lifecycle function, like a component to mount or something, and I stepped through into the React DOM library. Well, I can be pretty confident that my bug's not in here, so I blackboxed the script. This way, the next time that I step through a function that hits that file, the debugger will simply ignore it, and I can focus on my application code. You can also include patterns in the DevTools settings here, so I can blackbox entire folders, like node modules, for instance. So the DevTools debugger has a crazy amount of features. I can't cover them all. But yeah, so you can add breakpoints just on certain event listeners, like on the left here. So anytime I click on my browser, a breakpoint will be hit, and I can inspect the code at that point. And you can also do it when a DOM node is modified, like at the top here. So this info box div, if I add this break on attribute modifications, it will break whenever a class is changed or an attribute is changed, added or removed. And you can even add conditional breakpoints. So this means that your code is only paused when a certain condition is met. This is really useful for when a certain function, say a React render, is called multiple times. But the first time it's called, my mysteries data here isn't going to have anything in it because the API hasn't returned yet. And so I don't really care about that point in the code. So that's why I've put a conditional breakpoint in here to only break when there's actually data there so I can inspect it. So sometimes we might be in a situation where we have little to no control over the code that we're debugging. It might be some JavaScript on an environment that we can't reproduce locally, or the process of deploying our changes to our remote environment might be really frustrating and slow and painful. Debugging a critical production issue is stress city, and so working with a tricky infrastructure makes that even worse. So say you have a version of your application running locally, using a Chrome extension called resource override, like I've got here. I can proxy the call that my production website is making. So in this case, from bundle.js on the left-hand side to instead load my local version of bundle.js, which I've got on localhost somewhere. What this means is that we can change our code and test it within the larger environment where the bug actually occurred, rather than the kind of false environment that sometimes we have locally. Applications like Fiddler and my favorite Charles Proxy also allow you to do this, but with a lot more features, including the ability to monitor and inspect all the calls that your site makes. I've been on teams that have literally used Charles Proxy for their entire front-end development flow, because many big applications are tricky to set up locally. And trying to keep the back-end architecture and the APIs and your front-end up to date across all different teams is, it can be really painful. So if you have a reliable staging environment, then proxying your front-end files is a nice way to skip that setup entirely. So a slightly different approach is available in Canary. Make sure you first enable override network requests in the DevTools settings. And then you can click on the Sources tab, go to Overrides, set up overrides, and select a folder on your hard drive. And then give Chrome access to it. And then make your changes in the DevTools. So here I'm going to make the Reddit background purple. And I'm going to save, and you can see I've got this purple dot now indicating that it's being overridden. And then when I refresh, the changes are persisted. This can be super useful. So yeah, the previous solution using proxies is great if you have a local version of your code that you can map to, but this is perfect for when you don't have that set up and you just want to change something simple to test it. So a lot of the technology that I'm covering either is seriously enhanced by or doesn't work at all really without source maps. So a quick refresh. A source map is a file that allows the browser or other technology to map the compiled or compressed code back to its original file. So yeah, it's another really important tool that helps us with debugging. Minified code is pretty impossible to debug properly. So on the top, we're inspecting a website without source maps. You can see that all the variables have been mangled and the ES6 class has been transpiled. Whereas on the bottom, source maps have been set up. You can kind of see it here, source map from main. And it actually looks like the code that we wrote. Depending on your build process, they're pretty easy to set up. And most importantly, they only get downloaded when you open the DevTools, so they won't affect your application or its performance. Okay, so that's the browser. What about Node? Well, you can actually debug Node in the Chrome DevTools. You just need to run your Node script with this flag, and BRK, by the way, means to break before your code starts so that you can put your breakpoints in straight away. And then you can either click on this green Node icon in any of your DevTools windows or on the open dedicated DevTools for Node link. And if you like this workflow, then you should check out the Node Inspection Manager extension, which manages all your scripts in your windows for you. But let's get to the really good stuff. So integrating debugging in the editor has been around in various forms for ages, but many JavaScript developers are either not aware of it, they think that it's too tricky to set up, or they don't want to change their debugging mindset because they don't think it's worth it. Well, I'll let you be the judge, just make sure you give it a go first. So fortunately, we have a lot more front-end focused editor options now, some of which include inbuilt debugger. So I'm going to focus on VS Code because I love it. It's really light and it's easy to use and it's fast and it's what I use every day. And I promise I'm not trying to sell you anything because, I mean, that would be dumb because it's free. But yeah, there are other IDEs like WebStorm that also include an inbuilt debugger. And the idea is pretty similar. So I'm going to take you through my debugging process and how I set it up using a mini front-end React app that talks to an Express server. I've added a couple of spelling mistakes just to simulate the idea of what it might actually be like to debug a error. So a typical process for debugging a front-end application might look something like this. We open the browser, we have an error in the console. Okay, we go to the editor, console log out some of the variables that we think might be causing that error. Back to the browser, refresh, or maybe a hot module reload. And if we're lucky, we've chosen a variable that helps us determine how to fix the bug, if we're lucky. Back to the editor, make the fix. Back to the browser, refresh. Okay, great, finally fixed. It's a hell of a lot of guesswork, and it's a lot of switching back and forth. So let's see how we can improve that flow. So VS Code has a bunch of extensions that let you debug tons of different languages in different frameworks. The most useful for us is the Debugger for Chrome extension. It's actually framework agnostic, so you could be using Vue or Angular or jQuery or whatever you like. But I'm going to show you the configuration for my React app. So first of all, we go to extensions. We look for the Chrome extension. We install it. And then we reload VS Code. Super quick. Okay, cool. Let's go to the debugger and add a configuration. We just now need to look for the Chrome launch configuration. And the only thing we need to change here is the URL. And I'm changing it to localhost 3000 because that's what Create React App uses by default. Save that and press play, and with any luck, ta-da, we have our app. And this is loaded with the debugger ready to debug. There's absolutely no other setup or settings anywhere. And the debugging experience is also really nice. So here we have a bug. We've got the quotes are missing, they're not showing up. So I'm going to go into my editor and add a breakpoint. And then refresh. And I can see that some of the properties are coming through, but yeah, quote is undefined. Okay, that's weird. I can have a look in the code here and go up a couple of levels and check out my state. So this is my React state, and there is, quote, it's spelled with an E. Okay, great. Go back into my code, fix the bug, remove the breakpoint, refresh. Ha, magic, fixed. And I literally didn't even touch the browser. So yeah, similar situation occurs with Node. So a typical workflow if we're dealing with, say, a Node API might be something like this. We start with an error in the terminal. We switch to the editor, write a console log to check a variable. We switch to Postman or another terminal to run curl, or a browser to run our app, however we want to hit our API. Switch back to the terminal to see the results. If we're lucky, we can write a fix for it. Hit the API again and hope our bug is fixed. So again, we can really clean up this workflow by doing so much more in the editor. Here's how to set it up. So I have a bug on the right-hand side, server area. My mysteries route is not returning anything. And so I'm going to add another configuration. And this time I'm going to use the Node launch program configuration. I don't have to change anything because my entry point is app.js. And then I press play, and my API is now running. I'm just going to quickly test that by pinging it, and hey, it returns Pong. Okay, great. So once we have that debugger running, we can hit this broken mysteries endpoint with our React application and easily debug what's going on in our Node API. So I'm going to add a breakpoint to my mysteries route, refresh to hit it, and you can see everything looks legit. Okay, we're getting the request through correctly. So I'm going to step through my code. Everything looks fine. Okay, we've hit an error. Misters is not defined. Okay, apparently I'm a terrible speller. So I'm going to go through and fix my bug, remove the breakpoint, refresh, and then hit the API again by refreshing my app. And it's fixed. Magic. So the even cooler thing is that VS Code will let you make compound configurations, meaning that you can debug your front and your back end code at the same time over multiple and different languages and frameworks. So yeah, one more thing before I finish. I should just quickly mention that in no way have I covered this space. I've obviously had to focus on one browser and one IDE, and I didn't even touch on mobile, performance, HTTP debugging, just to name a few. There's so much more to explore. And of course, accurate and realistic test coverage is an extremely important and useful way to prevent bugs in the first place. Also provide a quick and easy way to test fixes and prevent bugs from occurring again. So the golden rule is once you fixed a bug, make sure there's a test for it. So the last thing I'm going to leave you with is this. If for some reason you're going to stick with console.log, that's fine. Just make sure you write a good snippet for it. And that's it. Thanks very much.
Thank you so much, Rebecca.